as part of our training run, we had generated a model. Those models are tracked in this model repo. So if I go to this model, so it shows the versions of the models that were generated. One was generated from the initial training run. The second one was generated by the hyperparameter tuning job. So you could deploy any of these. So this is how they are versioned. Each time you run it, a different version is generated. When I go to a specific version of the model, the lineage that was available for runs is also available here. It shows what code, what data set, and which run generated this model, right? And the name and this model, as well as the metrics that were also available in the run. So those are also available here. So going back to the model, so I can pick any version and publish it. The idea of publishing a model is a model can be deployed directly for inference, or it could be published into a model catalog. The idea of publishing is data scientist runs through several of his trials, and he would have a number of versions of models available. And he would look at an optimal model that he has derived and would publish that. He has developed and would publish that model to be available for anybody to deploy, actually. So publishing the model is this screen. So I'm going to give it a name. Publishing a model needs a serving image. In this case, the serving image is derived based on the framework that was used, but it could be changed to a custom serving image that the user provides. It also enables for the configuration of transformers. These do pre and post processing of requests for the inference. The code is provided in this repo or the repo that the user is working on. To access the code, the user would have to create a code repo. In this case, all the training code as well as the transformer code is in the same repo. So we use that repo and specify the location of where the transformer code is, mnistransformer.py. Quickly verify that I have the right path, the transformer script that you would configure. So once that is configured, you submit it. So the transformer, the pre and the post processing are used and deployed as a inference pipeline, where requests are first routed to the pre-processing pod, and then they go to the serving pod, which has the predict method, and then go to the post-processing pod, which has the post-processing method. The format of the code in transformer.py is prescribed by a KF serving, and that's available in the KF serving documentation. So in this case, we've published this model. So now we can actually deploy this model for inference. I'm going to deploy this for inference. What I would need to give is a name, and I'm going to keep all the other configuration that was configured during publishing. And I would say that this model is going to be deployed using a CPU. And you could also configure some scaling parameters, the number of pods that should be up and running all the time, as well as some soft target of when a pod should be scaled up. If this number specifies the number of kind of a target of how many requests a pod could serve. And once it reaches a percentage of that, concurrent requests reach a percentage of that, different pod is scaled up. And as well as if the traffic goes down, pods are scaled down. So we'll just give it a name and then just hit submit. And pods that all the inferences that are created show up under model serving. So the pod should start up. Once it starts up, this endpoint becomes visible. Basically, the endpoint at where the inference request can be served. So the pod is live now, and this is the endpoint where the inference request can be served. So if you click on the serving, it kind of tells you the format of the request. inference predict is expecting.